Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be talking about 3.3, which is dividing polynomials. This is a fairly covered topic in Integrated Math 2. We spend quite a bit of time on it, talking about different techniques. Because this is in Integrated Math 3, we're sort of condensing the strategies here. So we're going to talk about a couple of these, and we're probably going to spend more than one day on it. So consider this to be 3.3.1. So first, to start out, we're going to look at where we have to divide polynomial functions when we are dealing with both a polynomial in the numerator and a monomial in the denominator. So this might be something like 10x squared minus 6x plus 4 over 2, for instance. So we have a quadratic trinomial here. We have a constant monomial in the denominator. When you only have a monomial, the process is pretty straightforward. You can simply break apart the fraction. So I can do 10x squared over 2 minus 6x over 2 plus 4 over 2. So we break it apart into each of those different terms, and then you just divide as normal. So 10 divided by 2, 6 divided by 2, 4 divided by 2 here. If you need help with the rules of exponents, if it's been a while, remember that that's back in Unit 1. So if you want to go back and look at that video, that's available on YouTube as well. Okay, let's look at another example. Let's do 7x. Let's do 15x cubed minus 5x squared plus 10x divided by 5x. So we're going to take each of those separately because I only have a monomial in the denominator. I have 15x cubed over 5x. I have minus 5x squared over 5x. And I have 10x over 5x. So remember, with the coefficients, we're just simply dividing as normal with any other constant. With the rules of exponents, remember the rule is to keep the base, subtract the exponents. So we have 15 divided by 5. X cubed divided by x gives me x squared. For the second term, I have 5x squared over 5x. So 5 divided by 5 gives me 1. X squared divided by x gives me x. The 1 is optional. Remember, anytime you have a 1 as a coefficient, you can include it. You know, it's not wrong, but typically we won't write it. We'll just leave it as x. And then I have 10x divided by 5x, which gives me 2. So those types of examples are pretty straightforward, right? Where all we're doing really is breaking up the polynomial on the top. We're separated into different fractions, and then we're using our rules of exponents and our coefficients to simplify. When we get to the point where we have something other than a monomial in the denominator, let's say we have a binomial, well, then it becomes a little more complicated. And there are going to be some techniques that we talk about here. We're only going to cover a few today, and then we'll cover a few in next week's lesson. So if I'm looking at an example like this, x squared plus 6x plus 8 over x plus 4. Because the numerator is a trinomial of a quadratic term, that's something that I should be able to factor, just like we did in Math 2. So the goal here is to try to break it up and see if you can simplify the denominator and the numerator by having the same term. So you can do this a number of ways. You can use the box method. You can use the magic X. However your integrated math 2 teacher taught you. For me personally, if I'm doing this, I'm going to use the X. So I'm looking for two numbers that multiply to get 8, but add up to 6, which happen to be here 4 and 2. Because those numbers are 4 and 2, I can rewrite the numerator as x plus 4 times x plus 2. And now by doing that, I have a common term in the numerator and the denominator. Both the numerator and the denominator have an x plus 4, so I can cross these out, and that leaves me with x plus 2. Similarly, let's do x squared plus 6x plus 9, for instance, over x plus 3. There are some factoring techniques that you'll want to revisit for the Math 2 topics. And if it's been a while, again, I recommend that you guys go back and look at those videos. How to do completing the square, how to do special factoring techniques, how to look at special polynomials. Those are all under Integrated Math 2, Unit 2, if you need to go back and revisit those. Here, in this example, because the numerator is a special polynomial, I can rewrite this as a perfect square as x plus 3 quantity squared over x plus 3. Therefore, one of these is going to cancel out, and that leaves me with an x plus. So that basically covers half of this unit. We're going to be spending time for 3.3 as a class, dividing this topic over 2 days. These are sort of the easier examples, either involving simply breaking up the fraction and simplifying each term, or we're going to be looking at examples like this where I'm able to factor the numerator and then simplify to do the division. We are also going to be covering other techniques, for instance, using long division or synthetic division involving polynomials, but we're going to save that for next time. Anyways, guys, if you need help, please reach out to me. It's mturner@psasb.us, and I will talk to you soon.